spherical mirrors. If you observe the mirrors used by dentists, mirror used as rear view mirrors in automobiles, and mirrors used for shaving are not plane. These are called spherical mirrors. A spherical mirror is a part of a sphere. Consider a hollow glass sphere as I was seeing in the figure. Now you cut along this AB as shown in the figure. The part that cut off appears to be like a dish. If this portion is coated at the bottom, that is on the convex side, on the convex side or bulged outside or the outer side, the inner side or this concave side, it becomes reflecting surface. It acts as a mirror. This is called concave mirror or converging mirror. Now if this cut-off sphere, if this cut-off part is coated on this side, that is towards this concave side, then this surface acts as a mirror. This is called convex mirror. Now this is convex and this is concave mirror. Now let us try to learn some terms related to these mirrors. First we take pole. It is the geometrical center of the spherical mirror and this is the pole of the mirror. It is denoted by P. Center of curvature. It is the center of the sphere of which the mirror is part. Now this C is the center of curvature. And the radius of the sphere is called radius of curvature and it is denoted by R. Principal axis. It is the line passing through the pole and the center of curvature. Now in this figure, this PM is the principal axis. Principal focus. Suppose we consider the rays which are coming from infinity incident on this concave surface. When they incident on this surface, they follow the laws of reflection. Since this is the mirror, they will be reflected. At this position, if you draw a normal, this normal exactly meets the principal axis at center of curvature. Now this normal is nothing but the radius for this sphere. All the normals drawn on this surface, they meet at center of curvature. Now at this portion, it reflects following the rule angle of incidence is equal to angle of reflection. All the rays which are coming from infinity, which are parallel to principal axis, they reflect from this mirror, they meet at this point on the principal axis. And this point is called principal focus, that is, the incident rays close to and parallel to the principal axis. After reflection, converge at a fixed point on the principal axis in case of a concave mirror. This point is known as principal focus. Similarly, if we consider the reflection in case of a convex mirror, here also when a ray strikes this surface, it reflects as I was seeing in the figure at point of incidence. If we draw a normal, this normal meets at center of curvature, this principal axis. In this case also, angle of incidence is equal to angle of reflection. If we consider parallel rays, that is the rays coming from infinity, all these will reflect from this surface, and if you extend these reflector rays, these rays appears to be diverged from this point, and this point is known as principal focus for convex lens. That means incident rays close to and parallel to the principal axis. After reflection, they appear to diverge from a fixed point on the principal axis in the case of a convex mirror, and this fixed point is known as principal focus. Simply, principal focus is a point on principal axis where the rays from infinity after reflection will meet. Focal length. It is the distance between pole and principal focus. The distance between these 2 points is known as focal length, and focal length is denoted by F. Aperture. The diameter of the mirror is called aperture of the mirror. Now we discuss about rules for the construction of ray diagrams formed in spherical mirror. The first one is a light ray parallel to the principal axis incident on the spherical mirror after reflection passes through the principal focus in case of concave mirror and appears to be coming from principal focus in the case of convex mirror. This is the parallel ray. Where this ray incident, you draw the normal. At this position, the angle of incidence is equal to angle of reflection. And this ray appears to be coming from this point, principal focus, and in this case, this ray passes through the principal focus. If the light ray is passing through the principal focus, when it incident on this mirror, now this is the normal. Here also angle of incidence is equal to angle of reflection. In this case, it reflects parallel to the principal axis. Similarly, in this case, this is the normal. Angle of incidence is angle of reflection. In this case also, it is parallel to principal axis. A light ray passing through the center of curvature. If it incidents, already we know that the line which joins these 2 points, that is center of curvature, and any point on the mirror is the radius, which is normal to the surface. Therefore, when the light ray incidents through the center of curvature, it incident on this mirror along the normal. Therefore, it reflects back along the same path. The same you can observe in the case of convex mirror also.